So let's go ahead and start. Today we're going to start with first explain a little bit about rectangular coordinates. We have two axes or two lines that are they intercept at a 90-degree angle. Yes, those we call those rectangular coordinate or Cartesian planes, depending which way you're looking at. If you're in French people call it Cartesian plane. They're based on the guy that invented those planes or found. Normally, when we were talking about real numbers, we only have one line, and then we will graph a number or a point to represent a letter or a number. So for instance, if I have A equal, say 3, then I will count 3 units from the origin, which is this one, and then say this is where point A is. So we're looking at the location of A in one dimension. Yes? So we're looking at the location of A in one dimension. That's why A at that time, or when we were looking at it in one dimension, we'll only have one value, because that's one dimension. Now, when we're looking at rectangular coordinates plane, we do have two real axes. So we have one axis that is horizontal on this side, and then we have one is vertical on this side. So when we graph a point, we are locating that point in two dimensions. We're just saying how far it is on the x-axis or on the horizontal line, and how far it is on the vertical lines, and this is the location, yeah, of that particular point. So suppose we have a point A with some xy value. Because we specified xy, the first coordinate of the point is always the horizontal line. The second coordinate is always the vertical line. So now, because I called the first point or the first coordinate of that point x, I can simply say the horizontal line, we're just going to call it the x-axis, because I called that point x. And then the vertical line, we called it y. I can say this is the y-axis. Now, for any point A, the x value tells you how far away is A on the x-axis from y. So if I look at the y line, and whatever value in here I have, and I count, this is where A is going to be looking up, looking at the graph from top. Yes? So for instance, if I say, let's go ahead and take a look. A is 2, 3. Yeah? So that means what? If I want to know where 2 is, I'm going to measure 2 units away from the y-axis. So that's going to be 1, 2. So I know for a fact, if I were on top of this one, and I'm looking down, now wherever A is, it's going to be along this line. Yes? But because you're going to see it along this line, you're only going to see a point. Yes? And that point is going to look like it is where on x equal 2. Does that make sense? All right. Now, for the point 3, 3 tells me how far away A is from the x-axis. How far away A is from the x-axis. So another way, if I go to the x-axis and I count 3 units upward, it tells me A is along this line here somewhere. Yeah? So if I were to look at the rectangular coordinate system from on this case, from this side, right? I will just see A at point 3 right here. Yes? Because that's what we did. This line, you're only going to look at the tip of it, right? So you're going to see a point. And that point is going to look like where it is on y equals 3. So now, wherever those two lines meet, that's basically the location of A. That's the location of A. Yes? So now, the coordinates points, and those are, we call these numbers the coordinates of A. So we have the horizontal coordinate and the vertical coordinates. Okay? So far, so good? All right. So in this case, but however, the coordinates can, even though we're looking at distance, they can be positive or negative just to specify which direction I go. So the positive and the negative of the number tells me which direction on that particular axis I should go. So for instance, if I have a B with -2, say -1, if I have a point B from -2 to -1, so that means it's still, B is still which way? 2 units away from the y-axis, but it is in the negative direction. So now the positive direction go this way, the negative direction go this way. So if I go 1, 2, so now if I look from top, I'm gonna see the point B along this line. So it's gonna point to a -2 on the y-axis. And then the y-axis or -1 tells me how far away it is from the x-axis, right? So I'm here, I'm going to take -1 down here. So this is where -1 is. And if I draw a line, imaginary line, and I look this way, I'm going to see a point, and that point is going to show me which way the -1 on the y-axis. So now wherever those two imaginary lines meet, this is where my point B is. So the negative direction on the y-axis tells me to go down instead of up, and the negative on the x-axis tells me whether to go left or right. Yes? We use this particular coordinate system to specify relationship between two things. Yeah? And those don't have to be just simply x and y. And those things from here to here don't have to be just 1, 2, 3, 4. They could be, as long as, they could be any measure you want. So I can say this distance is 1,000. As long as, if this is 1,000, then this is another 1,000. So that when you get to the next step, it is simply 2,000, 3,000, 4,000. As long as you go uniformly like that. And it doesn't have to be 1, 2, 3. You can make it as big as you want. You can make it as small as you want, depending on what kind of numbers you are dealing with. So if I'm dealing with numbers in millions, there is no point of saying, oh, 1, 2, 3, 4, 5, I count all the way to million. Yeah? I can start with 1 million, 2 million, 3 million, 4 million, and so on. And if I'm dealing with numbers, let's say 0.7, if I put 1 here and then I want to go 0.7, I'm going to get it small, right? I can say, well, 1 is here, this is 0, this is 1. Yeah? And then 0.7, I can divide this into 10 pieces, right? 5, 6, 7, 8, 9, 10, and then I can say 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. This is 0.7. This is 0.1, 0.2, 0.3, 0.4, Why? Because my numbers are extremely small. So those numbers, how far apart they are, it's up to you. You make a decision how big or how small you want those numbers to be based on the given information you have. Clear? So we said we normally use those lines to represent relationship between two things. Now I said this doesn't have to be the x-axis. It could be, say, distance. And this line could be time, or this line could be time. This line could be distance. This line could be pesos. This line could be dollars. So you have a relationship between pesos and dollar, right? So we can represent them by anything we want. Let's make representation. For instance, let's say we have a magazine company and they give subscription to people and in years, and then this is the subscription, and let's say these are in thousand. Let me erase this line. I'll put it back when I need it. And let's say, for instance, in the year 2014, the company had 10,000 subscriptions. Yeah. Now notice, I didn't have to put 10,000 over here. Why? Because I specified here the numbers that I'm representing here are in thousands. Yes? So let's say in the year 2015, then they had, let's say, 15,000. 2016, say they had 20,000. 2017, let's say they had 15,000 again. Yeah. Of course, we can have a whole lot. We can represent this by a scatter graph on x-axis or on the rectangular coordinate system by simply writing these as points. Now, how do I write these as points, and how do I determine what they are? Well, let's go ahead and put my rectangular coordinate system. If you're given a choice, then first step you want to do is you want to choose which axis should represent the year, which axis should represent the number of subscriptions. And accordingly, the point change. For instance, if I choose the year to be the horizontal axis, then the first point on that line would be 2014, 10. Yeah? But if I were to choose the year to be the vertical axis, then the first point on the line would be 10, 2014. See the difference between the two? Depending on which one you want for your horizontal axis, which one you want for your vertical axis. Now, if you're given choice. If you're not given choice, then there will be specified which one is which. Yes? So let's go ahead and say this is the year. Yeah? And let's say this is the number of subscription, and you can also choose whether you want to have those numbers written all the way or you want to have it the same way. I could say, for instance, number of subscription in 1,000, yes, and then go exactly what they have, 10, 15, 20, 25, whatever. But if I wanted to say number of subscriptions, then, and I didn't specify thousands, then I have to write down 10,000. Yes? So that's the only thing different between these. Yes? So just make sure how many we're talking about in there. Most time they give you the notation for what does the 10 represent. Is it just 10 subscription or 10,000 or 10 million, what have you? Yeah. So now I want to represent this. The only dilemma I have is it starting with 2014, and after that it goes by one at a time. So it doesn't make sense to say, well, this is 1, and then start going all the way to 2014. There are many ways of doing this. I'm going to show you a couple of ways. I'm going to tell you what it is. And you might see those on some graphs and how they represent it. One way they represent them is, they start over here, the origin, which is simply 0, 0. Yes? So now they want to divide here the years. They want to make sure to use an increment of 1. Yes? But they also want to make sure they want to show 214, 215, 216, 217. But they're not going to go 1, 2, 3, 4, 5, 6. So what they're going to do is, and I say, okay, what do I have? What kind of information I have? Between 0 and 2014, we have no information whatsoever. Does that make sense? So I can say, well, this is 214, yes? But then I made a cut here. Another way, this portion of the line, I bend it, cut it, whatever I did, I am not interested in showing it. Why? Because there is no information there. Yeah? So now I can go 215, 216, 217. Yeah? So even though I made my 1 increment a little bit big, but I didn't have to do it to represent anything in before 214. So that really didn't happen. Yeah? So now it is easier for me to go ahead and graph it on a small piece of paper to show what they are. So I'm going to say, now for the y-axis, again, it doesn't make sense to go 1, 2, 3, 4, 5, all the way to 25. But I noticed that all the numbers are divisible by 5, so I can go by 5. So I can go, say, 5, 10, 15, 20, 25, and so on. 5, 10, 15, 20, 25. Yep. So now I'm going to go ahead and graph every point and put it on top. So for the first point is 2014 and 10, right there. Second point is 2015 and 15. And then we just go 2016 and 20. And then we can say 2017 and 15. Yeah. So therefore, this is a representation of what that. We call that, because it only have dots on it, we call this graph scatter graph. So that gives me an idea at every particular instant available, then there is a dot in it. Yeah. Now this is one way of doing it. Another way most books use, they would say, let, say, year 2014 equals, say, 0. Yeah? So now, if I let the year 2014 equal 0, my line will be like this, 0. Right? Now, after 0 comes 1, right? But this is a 1, but in terms of years, it is which year? 2015. And then to 2016 and 2017. Yes? So I'm letting the first year to be 0. Or I could say year 2013 is 0, and then go 1, 2, 3, 4, and so on. Okay? But you must specify to your reader what is 0 represent. Does it represent year 0, or does it represent any other year? Because we can start time any place we want. Yes? We can start time any place we want. So this is another way of representation. Any questions? So that's a little bit of review on using points on a coordinate system. Next thing we want to do is we want to talk a little bit about relationship between two variables represented on coordinate system and rectangular coordinate system. So this is a relationship. We have y equal 2x plus 5. It's a relationship between x and y. And that relationship is represented by the equation y equal 2x plus 5. First of all, this basic equation we call linear equation. It's linear equation because the exponent on x and y are both ones. I don't see x squared, I don't see y squared, or I don't see x to the power 1/2, or what have you, or a square root. The only thing I see is x to the power 1. And the only thing I see for y is y to the power 1. Not -1, not just 1. So when we have that, we call this a linear equation. And a linear equation is a simple equation, and it's represented on a rectangular coordinate system by what we call a straight line. Okay? So this equation could be this line over here. Yeah? Now, every point on the line that is represented by that equation, we call that a solution to that equation. Yes, we call that a solution to that equation. So simply, if I say this equation, this point, this point, this point, this point, whatever the coordinates are of those points, those are going to be solution to that equation. And notice, how many points can I put on a line? Infinite. Yes? So that means if you have a linear equation, that equation has infinitely many solutions. So it doesn't have particularly just one solution. It has how many? Infinite. Whatever number is always one. That's what infinitely many solutions. Yes? However, we need some time to determine particular points on that line, whether they are solutions or not. If they are on the line, they are solutions. And sometimes we don't even know, because we haven't graphed the equation, we don't even know if that point is on the line or not. So consider, for instance, a point, say 1, 7. And I want to know if this point is a solution to that equation or not. Okay. Well, simply to know if that point is a solution to the equation or not, we can simply substitute the numbers given, and if the equation stands true, then they are a solution. If the equation is false, then it is simply one, not a solution. And how do I determine that? Just go ahead and substitute. Let's see, how do I substitute? Well, remember, we said the first number is for which one? For the horizontal. In terms of x and y, in terms of x and y, x is always given as the horizontal. Yes? Unless it's specified otherwise. So another way, if I want x to be the vertical line, I will let you know. Consider x to be the vertical line. But in general, if you're given a point x, y, then we know x is the horizontal line, and then y is the vertical line. Yes? So another way, this is your x value for that point. This is your y value for that point. And therefore, if that point is a solution, all I have to do is substitute those values and see if I get a true equation. Now, the equation says y equals 2 times x plus 5. So now what I have to do is just take away y, replace it by 7. Take away x, replace it by 1, and see what I get.
Good morning.
Good morning. So what do it? Let's go ahead and do that. So y is 7. So 7 equals 2 times 1 plus 5. Now, no, we don't know yet if they are equal or not. Yes? So normally, when you're checking equality, you normally put a question mark on top of the equal sign. Why? Because you're questioning. At the end, you will decide, are they equal or not? And then you can say, put equal or put not equal. Yes? So now this is what it is. So on this side, we only have one number. I don't have to do much with it. Here, I need to simplify and see what do I get. So if I simplify more, so this is equal, 2 times 1 is 2, plus 5. And now, I can conclude 2 plus 5 is how much? 7. And then 7 in this list. Are these equal to each other? Yes, they're equal. Then I put equal signs. Okay? Then I would say, because I get a true equation or true relationship, then I can say, well, yes, that point is a solution to that given system. So now I'm going to make a conclusion. My conclusion is 1 comma 7 is a solution to the equation. Yes? So now we determine that point is a solution to that equation. How about 0, 6? Is 0, 6 a solution to the equation? Let's try. So here y is equal how much? 6. And x equal 0. So we're going to say 6 equal 2 times 0 plus 5. I'm going to put my question mark. 6 equal 0 plus 5. Put my question mark. Yes? Now, what's 0 plus 5? 5. Is 5 equal 6? So my conclusion is 6 does not equal to 5. Now what's that tell me? What is that tell me? That tells me 0, 6 is not a solution. Now a question like that, all of this work is to determine this statement. Now if you don't write this statement, you didn't answer the question. It doesn't matter you did all of the work, but you didn't find a conclusion. It's like somebody going to Walmart and getting in there and going around everything, and they come back without buying it. Okay, you went to Walmart, so what? What did you get? Nothing. Same thing here. You started, you did the problem, you worked it out, you found this. You didn't specify what your conclusion is. You didn't solve the problem. Does that make sense? So you really have to specify. When a question like this arises on a test, you must specify it is a solution or it is not a solution. Fortunately for you, on my math lab, it will ask you yes or no, for instance. But if you're doing a test on a paper and you don't put that, you got it wrong. Okay? So you have to specify what is the conclusion for that particular question. Yeah. We said if we give him points, it is nice. We can put the points in there, we can graph, we can connect them, we can do it. How do I graph a linear equation without any given points? Let's take that equation. Let's make a little table. First, to graph a straight line, if I have 1 point, I can have infinitely many straight lines through that point. Yes? And each one is unique. So I need certain number of points to graph a unique straight line. How many points minimum do I need to graph a unique straight line? At least two. So if I have 2 points, within 2 points, through the 2 points particular, you can only graph one line. You can go any other way. If you want, you can have another point just to make sure those 3 points are simply collinear. Collinear means they are on the same line. So another way, if you put the 3 points, because with 2 points, you can make a mistake and not know what it is. You did. But if you have a 3 points, you can have a point here, point here, point here. You graph a line, you missed that point. What happened? Something went wrong. Yes? Right? And if the 3 points happen to be all aligned, then you say, oh, okay, I did it right. Yes? So now, I'm going to do this, but we're going to only use 3 points. So we got 4 minutes, we can do that. All right? How do I determine which points I want? Now, remember what I said. I said there are infinitely many points on the line, right? So we just needed 3 of those. How do I determine which 3? Now, you can get, if you have an x value, then you can figure out what the y value goes along with that x value. Because every x value has a unique, in this case, has a unique y value, right? So I can determine the y value goes with the x by simply substituting the x value in there. Yes? So where do I get the x value? I'm going to get it from wherever you want. You're going to have a bag full of numbers and pull a number out. Or you can say, oh, no, I want to use this bag. Make it easier for yourself. Don't write all these numbers down and put in a bag and take. Just say, I want to let x be, say, 0. What happened when x is 0? Can I determine the value of y when x is 0? Yes, by substituting. Yeah. So we say y equal 2 times 0 plus 5 equal 5. So 0, 5 is my first point. Choose another number. 1, for instance. Let me make x equal 1. If x equal 1, what is the value of y? 7. We did that just a second ago, right? And how do we do that? Again, we substitute x for 1. 2 times 1 is 2. 2 plus 5 is 7. Yeah? Now, another one to check. I'm just going to choose negative 1. Yeah? If x is negative 1, so what do I get for y? Y equal 2 times negative 1 plus 5 equal, let me put the equal here. 2 times negative 1 is negative 3 plus 5, I'm sorry, negative 2 plus 5 is equal to 3. Yes? So now we have negative 1, 3, negative 1, 3. Now we can go to the rectangle coordinate system. We can draw a line. And I can choose the points 0, 5. So 0, 1, 2, 3, 4, 5. This is my first point. Yeah. And then we have 1, 7. So let's say 1 here, got a 5, 6, 7 there. And then negative 1 and 3. We have a negative 1 here, 1, 2, 3 here. And now notice I connected this point. The arrows mean the line continues on forever on either side. And it happened to be the more accurate your graph is, the more accurate your line is. Yes? So those 3 points are on the same line. They are collinear. I know I graphed it and it's correct. Yes? Any questions? All right, so I think that's where we're gonna stop today.